A commodity has a demand function modeled by lowercase p equals 118 minus 0.5x, and a total cost function modeled by capital C equals 40x plus 33.75, where x is the number of units. What unit price in dollars yields a maximum profit? Well, first, we need to think about profit, that is revenue minus cost. We're not given a revenue function, but we can create one by multiplying x times our price function. And so that's the first thing we're going to do. Revenue is equal to x times p. P is given at the top. Distributing x, you get 118x minus 0.5x squared. Now we can build profit function by taking revenue minus cost. Cost is given. Subtracting like terms, we have a negative 0.5x squared, 118x minus 40x, that's 78x, and then minus 33.75. If we're going to maximize profit, we need to take its derivative and find its critical number. So if we take capital P, take its derivative, that's negative 1. 0.5 times 2 is negative 1. Take 1 off of our power, that's also 1. So the derivative of this term is negative x. The middle term's derivative is 78, and any constant has a derivative of 0. Setting our first derivative equal to 0 gives us 78 units. Go back up to the price function, lowercase p, and we're going to take the demand function or price function, and we're going to substitute in 78. That's step 4. The price of 78 units, 118 minus 0.5 times 78, gives us $79 per unit. When the profit is maximized, what is the average cost in dollars per unit? Well, average cost is total cost divided by x. From the original problem, total cost was given as 40x plus 33.75. Dividing each term by x gives us, well, I tell you what, since we're only going to substitute in 78, I'm not going to worry about reducing. Substituting in 78 into both of these x's, 40 times 78 plus 33.75, get that grand total in your calculator and then divide that by 78, and you should find $40.43 per unit will be the average cost in dollars per unit if you're looking to maximize profit. Let's do one more like that just for the extra practice. A commodity has a demand function given by 102 minus 0.5x and a total cost function modeled by capital C equals 30x plus 37.75. X is still the number of units produced. What unit price in dollar yields a maximum profit? So like we did in the previous example, we need to build a revenue function because one is not given. And we can do that by taking x times our demand function. So x times p distributing is going to give us 102x minus 0.5x squared. Profit is revenue minus cost. Revenue we just built minus cost, which is given. Subtracting like terms, negative 0.5x squared, 102 minus 30, that's 72x, and minus 37.75. Maximum profit will occur when its derivative is 0, so our first derivative is negative x plus 72. Set that equal to 0, solving for x, you will get 72 units. Now that we know 72 units will maximize profit, we can calculate the price recommended for 72 units of production. So let's check that out. Step 4, we look at the price of producing 72 units, 102 minus 0.5 times 72. Carefully put this in your calculator. Half of 72 is 36. Take that from 102 and you'll get $66 per unit. That will be the price per unit that maximizes profit. When the profit is maximized, what is the average cost in dollars per unit? Same way we did it on the previous example. Total cost is given. We build average cost by taking total cost dividing by X, substituting in the 72 units that maximizes profit. Carry out your calculation. Calculate your numerator all the way. Get that grand total, then hit divide by 72. You should find $30.52 per unit. Consider the profit function, capital P, is equal to negative 0.1s cubed plus 6x squared plus 400. Find the amount of advertising in thousands of dollars that maximizes the profit, also in thousands of dollars. So we're asked to maximize profit. Luckily, we are given the profit function. That'll speed things up. Let's take our first derivative. That's negative 0.3s squared plus 12s. 400 will have it's a constant, so its derivative is 0. And then to get the critical number, we take our first derivative, set it equal to 0, and try to solve for s. Both of these terms have an s in common, so I'm going to factor out an s. That will leave negative 0.3s plus 12. And if you don't feel comfortable, make sure when you redistribute, you got to get the line right above it. This factor equal to 0. This factor equal to 0. Subtract, let's see, I tell you what. Now this one, s equals 0, we don't worry about it because that would just mean they're not spending anything on advertising. This other factor, if we add 0.3s, it becomes positive. The 12 stays positive. 12 divided by 0.3 gives us 40, but pertaining to the problem, this 40 represents 40,000 spent on advertising. Find the point of diminishing returns. I recopied the profit function down here, so you'll see it highlighted, but it's the same function as at the top. The point of diminishing returns is where your second derivative is equal to 0. It's where concavity changes from up to down or from down to up. It's the point of most rapid acceleration or deceleration. We don't really need to know the physics behind it, but I do want to point out that in this kind of a problem, it is sort of where the juice is no longer worth a squeeze, where if you spend any more on advertising, your rate of profit doesn't increase as fast. So you can still make more money, but it just doesn't increase as fast as it does until you hit the point of diminishing returns. As far as the math goes, take your first derivative. Again, the original profit function is highlighted. We have the first derivative from part A. Taking the derivative of this is negative 0.6s plus 12. Our second derivative, this is where our concavity will change. Add 0.6s to both sides, you get 0.6s equals 12. Divide by 0.6, and that'll give you 20. Now what this is the amount of money spent in advertising. This 40K at the top of your screen that was in green, that is the amount of advertising that maximizes profit. What we're finding down here is the amount of advertising where if we spend any more than 20,000, our profit can increase. It just won't increase as fast as it does until you hit that mark. Anything above 20,000, you can still gain profit. It's just not gaining as much speed as it was until you hit this mark. The profit of 20,000 in advertising, when you carefully put this into the original profit function, substitute in 20, Your answer will be 2,000, and that's what WebAssign's looking for. So from the first part, we got 20. The second part, we've got 2,000. This is actually your point of diminishing returns, but with respect to how the problem is phrased and what we're after, the point of diminishing returns is when 20,000 is spent in advertising, you will have a $2 million amount of profit. I hope this video helps out. Reach out if you have any questions or have any concerns. Catch me by email, phone, or swing by the office if you're on campus.